Hello everyone. I am here to give a teaser on my paper which is on the effects of audio coding artifacts on acoustic scene classification. Professor Dr. Nils from the International Audio Laboratories Erlangen and myself Nagashree, a student from Friedrich Alexander University, Erlangen-Nuremberg, are the authors of this paper. Classification models for understanding complex acoustic sound fields are becoming increasingly robust and accurate. The evaluation scenario indirectly presumes that scene classification is performed on the capturing device. However, many mobile and IoT devices are resource constrained and may not be able to store and execute all proposed classification architectures. The state-of-the-art classifiers demand significant processing capabilities and memory for good performance, which is challenging for resource-constrained mobile or IoT edge devices. It is more likely to deploy these models on more powerful hardware and classify audio recordings previously uploaded from low-power edge devices. In such scenario, edge device may apply perceptual audio coding to reduce the transmission data rate. So, here we want to discuss the effects of perceptual audio coding on the classification accuracy. The goals of this paper is to gain understanding on how perceptual audio codecs affect the performance of DCASE applications and to investigate if audio coding could be a beneficial strategy for data augmentation during training. Thanks to the authors of Device Robust Acoustic Scene Classification based on two-stage categorization and data augmentation 2020, who made source code and pre-trained models publicly available. We are able to study the effect of audio coding artifacts on one of the best performing models of the DCASE 2020 Scene Classification Challenge Task 1. They extract features from audio using log-mil filter bank and apply it to the ensemble classifier. These features extracted is sent to the two groups of the ensemble classifier. The first group is a 3-class group and the second group is a 10-class group. The 3 classes in 3-class group are indoor, outdoor and transportation. The 10 classes in 10-class group are airport, shopping mall, metro station, pedestrian street, public square, street traffic, tram, bus, metro, park. The combined output of these ensemble classifiers result in the final classification score. To understand if a perceptual audio coding affects the performance of the model, we evaluated the state-of-the-art pre-trained model using lossy compressed audio files. Audio compression has been performed using FFmpeg on the evaluation fold of the DCASE 2020 development dataset. We used 5 different popular audio codecs at 2 different bit rates for this experiment. So the workflow is as follows. We have pre-trained model available and we evaluate its accuracy using the differently compressed evaluation data. The results of this experiment shows that the model accuracy decreased significantly and dropped by up to 57.1% due to the audio compression compared to the classification using original audio data. From this, it is clear that the perceptual audio coding affects the classification results negatively. So how can we improve the model performance in such scenarios? Our solution is to include perceptually coded audio data as augmentation data along with uncompressed training data during training. The original authors used augmentation data from speed change, pitch change and reverberation, etc. We use augmentation data that is generated by converting the training dataset into different encoded audio formats and bit rates. We focus on the 10-class FCNN model in this experiment. The models obtained from this training are then again evaluated with coded audio files of the evaluation fold. We experimented with 7 training conditions. You can find about this details about these training conditions in our paper. The newly trained models are evaluated with different codecs considering 4 conditions. No coding conditions. Here, inference is done using the original evaluation data. That is, the uncompressed evaluation data is used. Scene codec with scene bitrate conditions. The evaluation conditions use codecs at known bitrates that were part of the training. For example, MP3 at 64 kbps was part of training and evaluation as well. Unseen bitrate conditions. The evaluation conditions feature the same codec used for training but at different bitrates. For example, MP3 at 64 kbps is used in training, and in evaluation we use MP3 at 32 kbps. Unseen codec conditions. The audio codecs that were not part of the model training are used for evaluation. These codecs are unknown to our models. We got some interesting results for all these conditions. To learn more about our results and details about our experiments, please have a look at our paper and visit us during the poster session. Thank you.